Okay, so you've been listening to my lecture for quite some time now. I will show you a demonstration to break the monotony of the situation. So we talked about supervised learning, unsupervised learning, etc., and I try to explain that to you. Now, let's see supervised learning in action. So we have a problem where we have to identify handwritten digits. Okay, so let's see how machine does it. So I have a data set which contains input data. This is a very classical problem. This data set was prepared long time ago in US, and when I'm just loading the data set first, and we'll see how it works. So you see, I have got 60,000 data, which is the training data, and 10,000 data, which is the test data. So now I do some pre-processing on this data. So don't bother about all these things now. We will discuss all these things in details. And I will just show you some images, what is available to us. So you see that these are the images. So only this is the part of the image, and this is the label. I I have labeled it saying that if the image looks like this, it's a 2. If it looks like this, it's a 6. So I have collected different data samples. So if it looks like this, still it's a 6, and so on. So I have 60,000 such images for training, and using these images, I'm going to tell the machine, you learn to identify different digits. So if it's information like this, it's a 0, and so and so. So now this is just a descriptive statistics where I say that I have got so many number of images regarding different digits. Um, and you can see that the data of the images, they are all numeric. So uh, what this it says that the first image is of a 5, next is a 0, 4, 1, 9, etc., and I represented. So what this means, I will tell you in later on classes. Don't bother about it right now. Then I create a, so okay, appreciate that I have got data where I know the input. So this is the input, and I have labeled it. I have said that for this input, this is the output. So I can apply supervised learning. The input and output both are known to me. So based on this circumstance, I create a model. So this is a model I create, and I tell him, okay, fine, you train yourself. Um, so it will start training itself. Now, yeah, it is training itself. Now you see that training is very expensive process. So it is using a GPU. You can see here. Now GPUs don't come for free. You have to pay for them. And this is a very complex model. So I cannot use a normal CPU which comes for free. Instead, I have to use a paid version of to get the model ready. So now how exactly this training, we will go through all these things in later sessions, but it is training itself. It is learning from the data what I have provided him as input. So now we will have to wait before the training is completed. So it is training itself. Just hold on for a little while. It will complete training now. I will come back to this example many times in this program to different aspects of different concepts. So this was not in the original plan for today, but nevertheless, I thought that you're listening too much to me. Let's see something in action. You can see that even for a simple model, it takes a reasonable amount of time using high-end machines also to train the model. So it's a very expensive process. It's expensive process in terms of time and money both. So it's almost done now. Just hold on. How come there are people joining in still? We have covered more than an hour of the class today. There's still some people joining. It is still training. You can see that. It's still training. You see a few things that it is now reached accuracy of nearly 100% in terms of how it learns from the training data. So if you notice, initially it was uh, much lower in terms of it is 94% accuracy, and now it's almost 100% accuracy. So gradually it learns to make itself better. Okay, so it has finished training itself. Now let us evaluate the model. So when I evaluate the model, it says that it is producing results at 99.54% accuracy. So now let us see a practical side of it. It is saying that from the test data, it will identify all these cases correctly. So if it was a 9, it identified it as a 9, and so and so. But it made some mistakes also, but mistakes were very few. Now what we can do is that we can do a unit testing where I take a test data at random, let's say 200 first data, and I tell you make a prediction on this. So it says that 200 first data is something like this, and the prediction is 6. So you see that it is doing it correctly, is it not? Yes or no?
Yes.
Yes, right? Let's try another sample. Let's take 2015. And so this is the image, and it says this image represents 1. So it's predicting correctly. You can see that. Take anything else. Take, so this is the number, and it says it's a 2. So you see, I gave him the input data. Based on the input data, it learned to create the rules, and now it is giving me a prediction based on any test data what I'm giving him. So did it give you a better understanding of what machine learning process is all about?
Yes, sir.
Okay. So that was just to break your monotony, and I now return back to my slides. So any questions about this so far? No questions. Okay. We'll now look at a neural network. Neural network we'll discuss in much more detail. Yes, Tarun.
Yeah. Um,
So the example you have shown is what it will be a cluster or it will be a continuous or a discrete type of example where the data learning happen on its own.
Okay, I will answer you, but let me see if anyone from within your cohort can answer it. Anyone would like to answer, Tarun? What kind of a problem it was?
It's discrete, right?
Discrete. It is discrete because it is generating
A defined.
1, 2, 3, 4, 5, 6, 7, 8, 9, 0. 10 outputs, right? 10 distinct outputs. And what kind of a model we prepared? Supervised learning model. And what kind of a supervised learning model we prepared?
Classification.
Classification problem. Is it clear?
Yes, sir.
Okay. So we'll go through this portion much more in details later on. For now, you understand that we have a human uh, neuron which looks like this, and we try to this neuron has got some parts in the human beings. Um, what happened? So these are the dendrites. Dendrites basically capture information, and this is the body of the neuron where the processing takes place, and this is the axon where the signals are sent out to the neighboring neurons. So now we try to create an artificial neuron just like the natural neuron, where it takes inputs in some form, and then it has got a body. Only in the body we have got defined functions. One is the summation function, and one is known as the activation function. And after applying the summation function and activation function on the input, we produce the output. Okay, so this is what a neuron looks like. When I put together many such neurons, it becomes a neural network. So we'll discuss this in much more details, but for now, you just understand that we are trying to mimic the human system in the machine. I'm always very tired of Microsoft PowerPoint. It does strange things. Okay, so we will go through this in much more details, and just hold on your guns for till you come to the particular week for this discussion. This is a very complex topic. It is not easy to understand, so I don't expect that you would have understood everything at this point of time as well. So understand that we have something called as artificial neuron, which mimics the natural neuron, and using a combination of all artificial neurons, we create a neural network. And neural networks are utilized for solving machine learning problems. And these problems are solved using deep learning. Okay. So there are different kind of artificial deep learning models. So right now, just register the names. There's something called as multi-layer perceptrons, MLPs, which look something like this. Then there are convolutional neural networks you use basically for image processing. And then there are recurrent neural networks used basically for time series analysis. And then there are encoder decoders. These are basically foundation of transformers. So I'm going a little fast here because I will discuss all these topics with you much more in details later on. Right now, I'm just registering these names in your minds so that you can start exploring and start reading something about it from the available documents which you have access to. And we will have to discuss all this in much more details. A few more terms which I will embed in your thoughts is that we need to evaluate machine learning models. So how do we evaluate? We evaluate by many parameters, like one is mean square error. What is mean square error? we take the actual, we know the output, right? In supervised learning, we know the output. So this is the actual output, and this is the predicted output. I find the difference between the two, and I square it, and I sum up all the predictions and find a mean for that. So this is what is known as the mean square error. So this is the error. This is the error. And when I do a square, this becomes error square. And when I find a mean of this, it becomes mean square error. So that's how it becomes mean square error. So instead of finding the square, if I find the absolute value of the difference between the actual and the prediction, I arrive at mean absolute error. And if I divide the absolute error by the actual, then I get the mean absolute percentage error. So these are all the different evaluation parameters which we will utilize to evaluate how good our model is. Now, intuitively, I'm asking you a question. What is better, a small mean square error or a large mean square error? What do you think?
Small. Small means error.
Yeah,
Small error.
if I get a small mean square error, my model is likely to be better.
Better.
Okay. So similar to regression, I have some mechanisms to evaluate classification problems. Classification problems, we basically draw something known as a confusion matrix. The confusion matrix tells me how many predictions I'm making correct and how many I'm making wrong. So if I have to predict a 0 and my prediction is actually 0, then I say that this many number of predictions are correct. Similarly, if my actual is 1 and the prediction is also 1, then I say that these are the correct predictions which I made. So this plus this put together are the correct predictions which I made. Then I make mistakes where I actually have a 0 but it predicts a 1. So this is a mistake. So this is a mistake. Similarly, this is also a mistake. So I made so many correct predictions, but I made some errors also. So based on this, if I take all the correct predictions and divide by the total number of predictions, I get the accuracy. Okay. And then I can calculate the precision and recall. This is also called as sensitivity. Sensitivity. And this is called specificity. These concepts have come from the medical world, and we will see how to understand them. Now, from the recent history, you will understand that when we had COVID, there was a RT-PCR test. Now, the RT-PCR test, scientists told that the chance that the test will produce the right result is 97%. That means to say it can make an error in 3% chances. So what kind of errors it can make? It can make two kind of errors. One is when the COVID is not present and it says COVID is present. This is one kind of error it can make. Or it can say that COVID is present, but it does not say that, no, sorry, this is COVID is present, but it says that COVID is not present. And if COVID is not present and it says COVID is present. So these are two kind of errors what it can make. So these are known as the false positive and false negatives. These have a lot of implications in deciding the betterment of the tests. So we will discuss these things. So I'm again planting some words in your heads. We will come back to this with examples later on in the program. I'm not waiting for answers basically because I will discuss all these topics much more in details later. And here I give you a reading where I've given you many applications of machine learning, deep learning. check if you agree or if you have more to add. I would like to listen to you. Anyone is working on any machine learning or artificial intelligence problems?
Yes, sir.
Okay. So what is the problem you're working on?
So my name is Triveni Hirimat. I work as a delivery head for a data analytics in one of the data analytics companies. So we actually work on many of the applications that you have mentioned here. Example for manufacturing where you have written, right? So I have built a lot of models on the supply chain optimization, both for production as well as the supply chain in terms of demand forecasting and inventory optimization. And in terms of retail, if you see again the personalized recommendations, what you have used the NLPs and we have built, and also sentiment analysis we have built using the NLP. Inventory management, again, like we build a lot of demand forecasting models and tie it back to the precursor and succeeding steps. Fraud detection, I have built my own personal projects, as well as when I was working with one of the insurance companies, we have built fraud detection models for the motor vehicle accident claims which come through there. So I have worked on many of the applications that you've listed down, sir, here.
Very good. Very good. Anyone else who has similar exposure?
Yeah, so this Yukumar, I'm part of a telecom company in India. So I see a good number of use cases or applications which is shown here. In addition to this, we are also working on automating an intelligent way of different fabrics that we are creating for customer deployments and design. So basically, we are reading all those requirements in this stage, and then there's a human intervention required. So through machine learning, especially using the GenAI models, different models, we are trying to understand those requirements, create a proposal or a design, project the cost, optimize solution to customer, and also deploying way of implementing through automated journey and management for customers. So that is something we are taken up as part of our organization
Very good.
initiative.
Okay. So you are in familiar territory. We will get more into details regarding many of these applications, and I will show you practical examples. Also, you will be doing assignments in which you will be solving such problems through the understanding what we're giving you in the classes. So we will see how it goes. Okay. So I believe that's all I have for you this week. I am giving you some books to read. These books are for non-technical people. These are all my books, by the way. And these books are for technical people. These are highly mathematical books. So these books do not contain any mathematics. So if you want to get into it, you can read these books and you can try and see whether they're useful to you or not. By the way, all the books are available on Amazon. And if you are an Amazon Prime member, you can read all the books for free on Kindle Unlimited. So you don't have to buy the books. You can read them for free if you are an Amazon Prime member. Okay. So now I'm giving you 2 YouTube links, and these links, go through them. So they will teach you, this particular link will tell you how machines learn regression. So go through this video. I cannot play it here because it will take about 30 minutes time to play one video. So I've given the links to you. So you go through them and see how machine learns to do the linear regression. Similarly, I given another video also. So how does machine learn how to do clustering? You can learn from this video. So go through this video. If you have any questions, I'll take it in the next week's class. So that's about it. And I will launch the poll now. And while you're answering the poll, I can take questions and I can try to answer you guys. So please take the poll and you can ask your questions and you can continue our discussion.